This is my final project for autonomous mobile robots. Echolocation. We decided on a pretty simple goal. Can we get a robot to track and follow sound while avoiding obstacles? Our system overview required an Amazon Dot which connected to the Amazon Web Services, where voice processing occurred. The mobile robot was controlled wirelessly by the control computer which gave it linear and angular velocities. The computer was connected to the USB webcam which looked at the Amazon Dot. Amazon Dots light up brighter in the direction the sound came from. The camera was used to determine which side lit up more. The camera was recording a video stream of the Amazon Dot. Image processing was done on each frame of the image to result in a binary image. A summation of the x and y coordinates of the white pixels gave us the center point of the white pixels. This could be then used to calculate the desired angle. To remove some of the excess light intensity, a physical filter was applied to the image. In this case, it was a cheap pair of sunglasses. Notice as the light spins around, we are able to accurately calculate the angle and display it. Each of the images are different stages of image processing. The next step was implementing a Kalman filter using first principles. This was done to give us a better approximation of the angle. Here is a test of the Kalman filter where artificial input data was generated. The data, represented by the red line, is noisy. The Kalman filter gives us a smoother approximation of the data, shown in the blue line. Finally, we test both angle generated by the image processing and the Kalman filter. You can see the Kalman filter gives us a much smoother angle transition. This information was then fed into a planner which generated velocities for our robot. Here is an example of the robot tracking my voice.
Follow, because it gets passed through a Kalman filter as well. Follow, and because there's a PID, so it has to build up if there's a small error. Hello.
Finally, we implemented obstacle avoidance. The obstacle avoidance uses a 3D camera. This camera is a replacement for a laser scanner and feeds out sensor data. We implemented a simple algorithm which determines how close an obstacle is and which side the obstacle is. We created a test where the robot was told to drive straight unless there was an obstacle in its way. You'll notice in the first test the robot avoids 2 obstacles, and in the second test the robot avoids the first obstacle and then avoids driving into the wall. We then put this all together. Notice the robot avoiding obstacles and moving towards the source of the sound. Here we show 2 examples of our final robot. There are, however, failure cases, such as when the robot starts tracking another sound. Here the robot drives over a metal cap, causing a clink sound. The robot finds the sound is behind it and starts to turn towards it.
There you go, Alexa, I'm over here. Alexa.
However, the robot quickly corrects itself and drives back towards me.